Life has existed on this planet for billions of years. Our span of time as observers only encompasses a tiny speck in the history of our planet. Species have evolved and gone extinct countless times, whether by meteor, mass extinction, geologic changes, or even more recently, human impacts. We are left with clues of the past in objects like fossils, but our knowledge of the Earth's natural history has largely been limited to the animals, plants, minerals, and bones we've decided to collect and save over the short centuries of our existence as natural historians. Our fascination with the natural world and our desire to collect and document its biodiversity hasn't really changed all that much through the years. What first began as cabinets of curiosities eventually became the museums and collections of today.
Through museum collections, we've built up these large databases of reference files. For example, viruses and trypanosomes and other parasites are vectored by mosquitoes. So by understanding which mosquito species feed on which hosts, we can better predict the pathways of pathogens.
The vast majority of what we know about our planet comes from collections just like this one. Each specimen is a snapshot of an ecosystem at a place in time.
When you consider all the taxonomic, evolutionary, and ecological information that is associated with just one specimen and multiply it by 3 billion, which is the current estimate for the number of specimens that you might call these primary specimens in all collections in the world, it becomes clear that there is more information about biodiversity, about nature itself, in natural history collections than in all of the other sources of information combined.
Digitization is the process of converting information into a digital format. With regards to natural history collections, this means taking all of the data from when the specimen was collected, including the specimen itself and any content generated during its history as a specimen, and putting that into a digital format so it can be shared with a global audience. After all, what good would all those wonderful specimens be if they weren't being used?
We could use those records from the past to understand things about disease and how diseases have changed over time, how habitats have changed over time. All from the comfort of the present without having to time travel into the past, we can actually get this information from the past. It's important to understanding the questions of today.
The reality is that having these digitized specimen data available makes my life much, much easier, and I'm able to get a much better, more complete picture of the full range of suitable habitat for these species.
There is an overwhelming amount of data and collections to be digitized. Photos, CT scans, images of the specimen, field notes. So what's the solution?
iDigBio!
No, iDigBio. iDigBio is the National Science Foundation's coordinating resource for the digitization of non-federal collections across the entire United States. iDigBio has 5 main objectives: coordinating the digitization effort, connecting people together both in the scientific community and beyond, teaching people digitization and collections best practices, aggregating and sharing collection data, promoting the use of scientific data and research and education. Species are disappearing from this planet at an alarming rate. We are powerless to stop these largely undocumented extinctions without a baseline for what exists here on the planet. We know more about the surface of the moon than we do about some of the ecosystems right here on Earth. So each specimen we collect is a treasure of biodiversity data that contributes to our collective knowledge of the planet.
Well, museum specimens are providing us with increasingly important information to help us solve a number of important societal problems. So for example, as we move into the 21st century, we see that many of our increasingly important societal problems relate to issues of biodiversity.
The problems we face are now problems. They're problems of the moment. They're not problems for 25 or 50 years. So when we talk about biodiversity loss, we kind of think it's in the future, right? Like it's going to happen at some distant point when our kids grow up or when our grandkids are there. But this is a problem of the now. And we really need to build out the tools, the people skills, the resources, the base to solve this problem today.
We can't even begin to predict the uses for specimens in the future.
There's all sorts of conservation concerns that can be elucidated, I think, through the study of specimens that have been digitized.
Until all of our collections are digitized, we'll never truly know what lies on the shelves and in cabinets and drawers of the many museums across the world. You can have the power to help in the digitization effort, no matter who you are. If you're a curator or a collection manager at a museum, consider working with iDigBio to publish your data through our portal. If you're a researcher, consider using biodiversity data in your study. You can get lots of information from the iDigBio portal, where tens of millions of records are housed from collections all over the world. If you're a citizen scientist, or just interested to learn more about iDigBio, check out our website or our partner organization, iDigBio, if you want to have a direct impact on the digitization effort. In addition, iDigBio also hosts monthly webinars on topics such as research, education and outreach, and collection use and best practices. They're free and open to the public, so all you have to do is tune in. We've come a long way, but there's still a lot to do. Through the hard work of the collections community, the National Science Foundation, scientists and citizen scientists everywhere, we've opened the door to our natural history collections. All we have to do is walk through.